Hey there, STEM Chemistry. This is Ms. Ruark. This is Vodcast 5.3. We're going to learn how to balance chemical equations. All right, so this is fun. Let's get started. All right, before we can talk about balancing equations, let's look and think about how molecules are symbolized. So you can have a diatomic molecule of chlorine and a diatomic molecule of chlorine. Where's my pen? It's not showing up. See if I can get this thing to turn on quickly. Quickly! There we go. Okay, so a diatomic molecule of chlorine is going to be chlorine, attached to a chlorine, right? And it's going to be happy because they all have 8 valence electrons. Okay, so you would see it as a chlorine attached to a chlorine, right? Okay, well here we have 2 chlorine atoms, which means we have a chlorine atom and we have chlorine atom. And that's it. They're not touching. They're just atoms. And here we have 2 chlorine molecules, so we have 2 of these, right? Or we could say like this. And so we would say we would have a total of 4 chlorine atoms and 2 chlorine molecules. Okay, that should be pretty easy. Okay, well we need to know that because when we're balancing equations, we need to be able to tell how many of each atom are in each molecule. Okay, you guys have done this already, but let's practice it again. So, sodium, there's 1, oxygen, there's 1, and hydrogen, there's 1. So we have a total of 3 atoms in this compound. For calcium hydroxide, we have 1 for calcium. There's 1 oxygen inside, but we multiply it by the number on the outside. So there's 2, and we do the same thing for the hydrogen. So there's 2 for a total of 5. All right, on this one, we've got a 3 in front. Well, if you've got a 3 in front of a variable in math class, what do? You multiply, right? If you've got a 3 in front of a parentheses in math class, what do? You distribute. So guess what, guys? We're going to distribute both ways. We're going to distribute this way. Okay, so there's 3 calciums. We're going to distribute this way, saying there's 2 hydrogens and there's 2 oxygens, but guess what? We also have 3 times 2 gives us 6, so there's 6 oxygens, and 3 times 2 gives us 6, so there's 6 hydrogens. That gives us a grand total of 15. That's not bad. You just got to remember that thing right there. Don't forget that thing. Okay. So, how do we balance an equation? So if you have the burning of magnesium, the law of conservation of mass says that matter cannot be created or destroyed. Atoms are simply going to be rearranged. That says rearranged, I promise, in a chemical reaction. So that means that what you have on one side might not be the exact same thing that you have on the other side, but the number of each atom will be the same. All right, so we have magnesium, and we burn magnesium in the presence of oxygen, because you have to have oxygen to burn things, and it forms magnesium oxide. All right, now the thing is, we only have 1 magnesium here, and we have 1 magnesium here. We're good, right? Well, you say, Ms. Ruark, you only have 2 oxygens, and you have 1 oxygen here, so your oxygens aren't good. So we need to fix that. Now, I'd already talked about this in a previous vodcast. I said you can't come in and change subscripts and you can't change the formula. The only thing you have control over is what goes in front. So we have to put a 2 here to give us 2 oxygens. But when we do that, that gives us 2 magnesiums. So we have to come back over here and put a 2 in front of this to give us 2 magnesiums. And now we're balanced. Okay, some of them will be this easy and some of them not so easy. But that's okay. All right, so balancing by inspection. That's pretty much what we just did on that one. So how do you do it? Well, you start with elements that occur in 1 compound on each side, right? And you want to treat polyatomic ions as if they're a single entity. Okay, so and you always want to do single elements last if at all possible. All right, so letter A, we have P4O2 and then P4O10. Okay, they're both single elements on this side. We can't do either one last because, well, you got to do one of them first, right? So let's just start with the P. There's 4 phosphorus here, and there's 4 phosphorus there. Yay! There's 2 oxygens here, and there's 10 on this side. So what can I put here that'll give me a total of 10? We can put 5, can't we? That was easy. Okay, let's try another one. All right, lithium. There's 1 lithium here and 1 lithium here. H2O, ooh, and H2 and OH. Ooh, but Ms. Ruark, you said treat polyatomic ions as a single entity. Well, the nice thing about H2O is you can change it from H2O into HOH, and it's the same thing. Oh yeah. So let's switch that into HOH. Oh, it's going to make it so much easier. Okay, I'm just going to kind of mark that out so we don't see it anymore. All right, we have one H on this side, and we have two H's on this side. Now you might say, but what about that? Well, remember, we're keeping that as a single entity, so we're going to put parentheses around it and pretend like it's all together. All right, we got two H's here, and we only have one H here. That's not good. So let's put a 2 here. All right, well, if we put a 2 there, that gives us two H's and two H's. We're good, all right? Well, we have two OHs, right? Because this goes towards both the O's and the H's. We're going to treat it as one, so we have two OHs. And we only have one over here. How do I know that? Because there's nothing written there. All right, well, let's put a 2 there. If we put a 2 there, that's going to give us two OHs. Yay! But it also changes our LIs, and so we have to fix that on the other side. And now we're balanced. All right, letter C and letter D. Ooh, letter D. That one's a fun one. Okay, letter C and letter D. I'm going to let you guys do those on your own, and then you can send me messages. You can remind me if you need help, or I think you'll get it, though. You're pretty smart. Or we'll just check it when you get back to class. Just a little hint. Polyatomic ion stays together. Okay. All right, balancing by atom inventory. 9 times out of 10, you'll be able to balance it by inspection, but there's times when it's going to be kind of tricky and you're going to have to balance it by inventory. So you'll set up a table to keep track of the number of atoms on each side of the equation. Now, the way that I do it is I write down each element that we have. So we have magnesium, right? We have hydrogen, and we have chlorine. And I write it like this. I put it down the middle underneath the arrow. That way I can keep track of my reactants on this side and keep track of my products on this side. Makes it easy to balance them out. All right. Let's see, what else do I have? Oh, no. Okay, so magnesium. I have one magnesium on this side, so I'll write 1. Technical difficulties. Oh, I think the button's stuck. Okay, there we go. Sorry. Okay, so we have one magnesium, we have one hydrogen, and we have one chlorine. Okay, on the other side, we have one magnesium, we have 2 chlorines, so we put that down here, and we have 2 hydrogens, so we put that there. Okay, we want these numbers to match up. But in order to make those numbers match up, we have to adjust the coefficients that go in front of those compounds. So our magnesiums are okay. We don't want to touch those. Our hydrogens, we need one more hydrogen on the left side to equal the hydrogens on the right side. So we come here. We need a total of 2 on this side. So I can put a 2 here in the front. When I do that, it gives me now 2 hydrogens. And it also gives me 2 chlorines. Don't forget to adjust. All right, oh, and look, we're all balanced. Yay, that's easy. Okay, now a big issue that I see here is a lot of students will come down here and adjust these numbers and won't touch your coefficients. And so your equation, if they do it that way, this is what I end up seeing. That. And that's not right, because that's still the same equation that's unbalanced. You actually have to include those coefficients to make sure that this is balanced, because this is what I'm looking for. When I look for the balanced equation, I'm looking for that. This that I'm scratching out is just your work. That's all it is. Okay, so here's some practice for us. All right, I'll do the first one to get with you, and then I want you to pause it and come back and check your work. Okay, for calcium, we have calcium and we have nitrogen. We have 1 calcium on the left side, 2 nitrogens on the left side. We have 3 calciums on the right side and 2 nitrogens on the right side. All right, to balance this out, we need to fix our calcium. So if we put a 3 in front of that, that changes this to 3, and we're good. I know, the teacher always does the easy one first, don't they? Okay, go ahead and pause it and try BiCl3. Come back and check your work. All right, so you should have, and when I say your coefficients, when I say your balanced equation, I'll just read out your coefficients just as they are here. So to balance this equation, you should have 2, 3, 1, 6. Hopefully you got that. I hope you did. Yay! Okay, go ahead and pause it. Try NH4NO3. and come back and check your work. All right, hopefully you got 1, 1, 2. I hope so. Is there anything? Oh, can't give you the joke just yet. All right, I'm going to do this one with you. This is a combustion reaction. We know it's a combustion reaction because oxygen is a reactant. It makes carbon dioxide and water on the side, product side. All right, so we're going to break this up into carbons, hydrogens, and oxygen. I don't think this is a tough one, but just in case. Just in case. All right, we have 4 carbons, we have 10 hydrogens, and we have 2 oxygens. On the other side, we have 1 carbon, we have 2 hydrogens, and we have a total of 3 oxygens. All right, let's start simple. Let's start first. We have 4 carbons and 1 carbon on this side, so let's fix that. We put a 4. That changes us to 4 carbons. It gives us 8 oxygens plus 1 more oxygen, so we have 9 oxygens. All right, we have 10 hydrogens on this side. We have 2 hydrogens on this side. So if we put a 5 here, that will change and give us 10 hydrogens. But it also changes our oxygens. Here we have 5 oxygens. Here we have 8 oxygens. 8 plus 5 is 13. Oh, no good. Okay, so if our oxygens end up uneven, and you know there's no way that you're going to be able to fix it, okay? No way you're going to be able to fix it. Come back in. If it's like this, come back in and put a 2 here. Well, no, let me do it this way. All right, we need 13 total oxygens on this side, but we have a pair of oxygens. So we're going to put 13 divided by 2. Okay, now we put 13 divided by 2 because we're saying we need a total of 13 atoms of oxygen, but we have 2 atoms of oxygen. Now the problem is you can't have a fraction as a subscript or as a coefficient, so you have to multiply this whole thing by 2. Why 2? Because we want that denominator to go away, right? So this becomes 2. This becomes 13, this becomes 8, and this becomes 10. And then you can go back through and check all your work to make sure that you did it right. Okay, so your coefficients there should be 2, 13, 8, and 10. And I know you're probably like, whoa, she did some magic there. I really didn't. It's okay. If you don't get it, it's not a big deal. We're going to do some practice problems like this in class, but I do want you to try it. Try a couple other ones, maybe C2H, C2H6 plus O2 makes CO2 plus H2O. See if you can get that one. You can also try C5H12, no, not C5, sorry. C6H14 plus O2 gives you CO2 plus H2O. So you can try these and see if you can get it. And if you're still not getting it, don't worry, come to class and we'll talk about it. Okay? All right, here you go. Thought this one was a good one. It's right up my alley. I'll see you guys later.